Alright guys, before we start this lesson, I want to make sure that you guys have downloaded and printed out the property sheets for the inverse trig functions, just so we can revert back to the domain restrictions, stuff like that. Okay, so today's lesson we're going to be mostly using our calculators and see how that works. Okay. So, example A, use a calculator to approximate the following values to 4 decimal places. Arc cotangent of 2. Well, if you look at your sheet for cotangent, first of all, we want to think of cotangent, we want to switch this to arctangent, correct? Because we don't have cotangent on our calculator. So let's go back to the domain restrictions, and if you look on your sheet, it should say that arctangent of x equals arc cotangent of 1 over x for all x is greater than 0, which is great because 2 is greater than 0. So I can look at this as arctangent of 1/2, and then I can do it on my calculator. Now make sure you are in radians, okay? So remember, you guys have a smaller calculator, but it's arctangent 1/2, and we're going out to the 4th decimal place. So our answer here is 0.4636. Okay. Now, if we look at secant and arc cosine, that works for all of x. Absolute value of x is greater than 1. Okay, so since that works, since absolute value of 5 is greater than 1, I can rewrite this as cosine of 1 over 5. So we do that again in our calculator, 1 over 5, and our answer is 1.3694. Alright, so I'm glad I wrote this down here because we have an issue here, right? Our x is not greater than 0, so we have to think about this in a different way. If you look, cotangent is from 0 to pi, right? So if we were talking about -2, it would be somewhere in the 2nd quadrant. Okay, again, I know this because cotangent is the top half of the unit circle, okay? So I know it's here. Now, how can I make that work knowing that tangent in our calculator are the first 2 quadrants? Because what's going to happen with our calculator is that it's going to give me something down here. Okay, well, what that means is I have to add on something. Right, so how much did I just add on? I want to move this here. I'm going to add on 180 degrees. So I can say this, change it as tangent inverse of -1/2. But then I would have to add pi onto it because I want it to be here, but inverse tan of negative 1/2 is down here. So I have to be careful where it's ending up. So let's do pi plus inverse tangent, there we go, of negative 1/2, and there we go. So our answer is approximately 2.6779. All my equal signs should be approximately, considering we are rounding. Alright, now let's think of this. Cosecant, we need the absolute value of x to be greater than 1. Absolute value of negative 3/2 is 3/2, which is greater than 1. So we're okay. That means I can do arc cosine of negative 2/3. Go on my calculator. Arc cosine negative 2/3, and oh, my mistake. Why did I say cosine? It's supposed to be sine. Gotta be careful on those. Hopefully you caught me before I figured this out. So let's go arc sine negative 2/3. There we go. Negative 0.7297. Alright, let's go to the next. We are looking at domain and range of the inverse function, okay? Now, let's remember some of our restrictions here. So, arc cosine, in general, and you can see that from the worksheet you were supposed to download, arc cosine of x, where negative 1 is less than or equal to x is less than or equal to 1. So x has to fall in between 1 and negative 1. Well, okay, our x is actually x over 5. So we want x over 5 to be between negative 1 and 1, which means if we solve this, we want x to be between negative 5 and 5. So our domain is negative 5 to 5. Alright, well that's the domain. The easiest way to get the range, guys, is to actually substitute in, and let's check it out. So negative 5 over 5 is negative 1. Arc cosine of negative 1 is pi, and pi over 2 minus pi is negative pi halves. Five divided by 5 is 1. Arc cosine of 1 is 0. Pi divided by 2 minus 0 is pi over 2. So again, guys, all I did was I plugged in and got my values. Alright, let's try this one. Well, the domain of just inverse tangent of x is all real numbers. Sorry, guys. All real numbers. So the only problem we would have with the domain if 4x had any restrictions, but 4x does not have any restrictions. So there are no restrictions by just multiplying 4 to x, so our domain is still all real numbers. Alright, so let's look at our range. Well, our original arctangent range, okay, let me label this domain and range so you guys don't get confused, goes from negative pi over 2, don't forget it's an asymptote so it's not equal, to pi over 2. Now if we look though, because range are the y values, what's happening to the y out here is that we have to multiply it by 3. So that's exactly what we're going to do. Since there is a vertical stretch of 3, that means our range ends up being negative 3 pi over 2 to pi over 2. Sorry guys. 3 pi over 2. Sorry guys, let me repeat that. Since we are going a vertical stretch of 3, our range changes to negative 3 pi over 2 to 3 pi over 2. Okay, just multiplying the original by 3. Cotangent, arc cotangent. We're dealing with the same thing as we did a little bit with tangent here. So cotangent, arc cotangent, the domain is all reals. And if we look at this of the x over 2, does it really have a restriction? No, it doesn't. So that means our domain stays all real numbers. Let's look at the range of a normal arc cotangent. Well, that range goes from 0 to pi. Now let's look at what the function did. On the outside here, we are adding pi, so that means we are shifting it up by pi. So really, we're going to add on to pi to the original. So our new range is pi to 2 pi. Alright, one more application here. So the roof of the house below has a 6 to 12 pitch. This means that when the view from the side, the roof line has a rise of 6 over a run of 12. If you look at that, guys, that makes a right angle. So let me label my 12 and my 6. We are looking, excuse me, we are looking for the angle right there. Now here's the biggest thing. It says express your answer in decimal degrees. Okay, if you remember correctly, our calculator is in radians right now. So either you can change your calculator to degrees, or we just have to convert to degrees after. Okay. So, of course, according to this angle, we have opposite and adjacent. So that is inverse tan of opposite over adjacent. When you plug this into your calculator, I will do that now. Inverse tangent of 6 divided by 12. Now don't forget, I am still in radians. So when I have this number, we are in radians, and the question wanted it in degrees. So how do we do that? Well, remember, we multiply it by 180 over pi. So I'm going to take this value times 180 divided by pi, and we get that our degree is 26.5651 degrees. If you want right now, you can change your calculator to degrees and just do your inverse tangent, and you'll see that you'll come out with the same thing.